So, dear B.Sc. 4th semester students, I wish you a very happy good morning, and let me start with the second episode of your syllabus Aldehydes and Ketones. Now, before I start, let me remind you this topic consisting of most chemical reactions involving mechanism. So, my intention is that let you people be familiar with the mechanisms, particularly name reactions in this topic. So there may be around 7 to 8 name reactions, of which 2 to 3 definitely may come in the examination. So please see that the every questions to be answered properly, provided you understood the subject in a good manner. So here in the first slide, just I have to tell you about what are the syllabus points. You know it. What are aldehyde and ketones, and what is the basic structure required for aldehyde and ketones. So you know this is the carbonyl group responsible for both aldehydes and ketones. That is C double bond O with the two valencies. If these two valencies are satisfied by an alkyl group and hydrogen, it is an aldehyde. If the two carbonyl groups valencies are satisfied by R and R, that is a aromatic or aliphatic group, then it is called as a ketone. So depending upon the type of valency satisfied by them, we can classify, or you can say this is an aldehyde or a ketonic class of organic compound. Okay, so in general we have this simple definition for you. Now we move on to the next slide, which already you all learned, nomenclature. So aldehydes are named as alkane. E is replacing by ANE, alkanal, okay, and ketones are named by replacing E of the alkane by ONE, alkanone, okay. So some specific example I have mentioned last time, the same thing, just I want to make you people to just remember them, not to by heart each and everything. So let us see how to name them in a proper way. Okay, so acetaldehyde CH2O, then CH3CHO is acetaldehyde, commonly called as ethanol, and CH2CO is formaldehyde, it is a methanol. If aromatic ring system is there, it is a aldehyde derivative, that is benzaldehyde derivative. Then ketones, where the two are maybe CH3CH3 for acetone, C2H5CH3 is ethyl methyl ketone, and they may be named according to this UPAC naming 1, 2, 3, 4, 5, 6 for a long chain hydrocarbon, and the position of the carbonyl group is treated with a specific number, and then it is a given. For example, the first example, 2-butane, but it contains carbonyl group. A is replaced by butanone, 2-butanone, 3-pentanone, etc. Just the examples I have mentioned. If there is a benzene ring attached to the RCO group, so generally they are known as phenones. Okay, so acetophenone. Okay, so acetophenone contains CH3CO C6H5. It is also called as phenylethanone. So some examples you have learned in a previous class, I have explained. Then regarding the structures of these aldehydes ketones. So the basic structure that you have to remember is the carbonyl group which is there. So the two valencies R and R dash with the carbon atom having pz orbital is connected with the oxygen that makes a sigma bond between carbon and oxygen is having pz orbital with lone pair of electrons, and these lone pair of electrons in the carbonyl compound plays an important role for most of the nucleophilic addition or reactions. So that is why the carbonyl carbon and carbonyl oxygen are most important functional groups in aldehydes and ketones. Okay, so these aldehydes and ketones generally represented by RCR dash, and the pi bond present on the carbon and pi bond present on the oxygen, they overlap. That is, pz orbitals overlap to form a pi bond, and there is a sigma bond. And the bond angle between carbon to R and carbon to oxygen, or carbon to R dash and oxygen. So it is 120 degree. So it's a trigonal molecule, and this trigonal molecule containing lone pair of electron is a very essential part for nucleophilic addition reactions for aldehydes and ketones. So all these things we all learned, but uh, as a point of discussion, I want to remind you why the structure of these carbonyl compounds are very essential to understand most of the chemical reactions. Right? Now with this, I would like to go with the same. That is, a molecule is a trigonal, one angle is 120. It is a planar with above and below the pi orbital located. In general, if you see the structure carefully, so this is a very important point, please note it, that the carbon with oxygen with the two valencies, oxygen is more electronegative with a lone pair of electron, that is the electron rich center, it is indicated by delta minus, and carbon is a deficiency of electron, it is indicated by plus. So that is the polarity of a carbonyl group. So in almost all mechanism we have to treat oxygen with minus delta, carbon with plus delta. So the pi bond electrons are in most of the cases shifted towards oxygen and exhibit a resonating structure formula I have shown in the second diagram, that carbon shifts its electron and become plus, oxygen gain the electron. Totally there are 2 plus 2 plus 2, that is 6 electrons, and is having a negative charge. And these negatively charged oxygen containing 6 electrons are again shifting towards the carbon, making the same carbonyl group. That I want to mention is they are resonating with each other. Okay, so this is a particular point one has to remember for understanding the mechanism point of all the aldehydes ketone reaction. Okay, similarly, you can see due to the plus and minus charge, the lone pair of electrons on the oxygen will have a dipole moment between carbon to oxygen, and the dipole moment for aldehydes and ketones are differ. Aldehydes are having a dipole moment of 2 point something, and ketones are having 2.8 because of the bulkier alkyl or aryl groups. Now, let us move on to nucleophilic addition reaction. Last time just I have explained it, but again I want to go through what is a nucleophilic addition reaction. So here just you can see in the nucleophilic addition reaction, as already I have mentioned in the previous slide, carbon is plus, oxygen is minus. When the nucleophilic reagent, what is a nucleophilic reagent? That is NuH. H is a electrophile, Nu is an nucleophile. Okay, so generally the reagent will break unsymmetrically to produce a nucleophile having a lone pair of electron, and the hydrogen which is having deficiency of electron. So nucleophile is a electron rich center having minus charge. Okay, then H plus is the electrophile, electron deficient center. Okay, now when the nucleophile comes to the carbonyl group, so ultimately carbon is positive and C double bond O will be minus delta. Okay, so here just you can see the nucleophile attached to the positive side, making the two valencies with the nucleophile attached to the carbon, and oxygen become negative. In the next space, a reaction, the H plus attached to the O and making hydroxyl group. So carbon with the two valencies and the remaining two valency in one nucleophile addition. Nucleophile addition takes place, nucleophile attacks, and O will become OH. So this is what we call as an additional product. And already I have explained last time, but it is better to understand. The nucleophilic addition reaction can take place in two ways. That is base catalyzed reaction and acid catalyzed reaction. In case of a base catalyzed reaction, the nucleophilic reagent is weak. It will react with the base. For example, we are using base like NaOH, KOH, or sodium carbonate, etc., or barium carbonate, whatever it may be. So these base will take the proton to form BH. So in generally I have represented as BH, and a strong nucleophile will generate, and this nucleophile will go for the nucleophilic addition or the carbonyl group. So that I will show in the next slide. Then acid catalyzed reaction. In the acid catalyzed reaction, here the addition of proton will occur first to form, that is CH. You can see CH double bond OH plus proton gives CH2OH and H. And this CH will get a positive charge. It will come in contact with the nucleophile next reaction step, and it will going to form the additional product like NH, CH, Nu and OH. Okay, so in general I have represented, there is a handwritten, so please don't get confused here. Whatever I have explained, the same thing will be explained with this diagram. Now you can see nucleophilic addition reactions of aldehydes and ketones, where the carbonyl group generally polarized to form plus and minus, having a resonating structure plus delta and minus delta. So please note this. This will come almost in all reaction as a common, keeping in mind that oxygen is minus delta and carbon is plus delta. Okay, so in the first step for the mechanism, the nucleophilic reagent NuH will break up to produce nucleophile minus and H plus. In the second step, the nucleophile attacks to the carbon positive to form anion. And in the third step, what happened? This anion will attack with the proton to produce additional. So the overall reaction you can view here, that is C double bond O, nucleophile attack will take place to the carbon, and in transition state will going to form, and whatever the carbonyl group is there, it is a sp2 trigonal structure. So a transition state is unstable, and a nucleophile attacks with the O minus, and it will become sp2 carbon anion in the second step, just by making minus delta to minus sign. Then protonation takes place by water molecule to give the additional product. Okay, so please remember these reactions. And already I have told you in the beginning, so in these reactions, general mechanism of a nucleophilic addition, I have made some effort to make you to understand. The carbonyl group C double bond O will shift its electron, lone pair of electron of the pi bond towards the oxygen. So minus delta will become minus, and the nucleophilic group will add to the carbon to form NuO minus. And in the next step, the protonation takes place to give the additional product. Now, this, whatever the mechanism generally I have explained, can undergo in two different ways. Mechanism of acid catalyzed reaction. So here addition of acid H plus will take place. And mechanism of base catalyzed reaction, in presence of a strong base, the nucleophilic reagent react to give, that is nucleophile, strong nucleophile, and the addition takes place. In both the case, the addition product is addition of OH and Nu, as I have shown in the beginning. Here, in this acid catalyzed reaction, the first step is attack of H plus to the carbonyl group. Okay, so to the carbonyl group to form C plus and H with negative charge, and the lone pair of electrons will shift towards the oxygen to form oxygen with hydrogen, and carbon will be plus charge, cation formation. In the next step, nucleophile attaches to the carbon and forms the nucleophilic substituted hydroxy product. Now in the base catalyzed reaction, the mechanism is little bit different. That is the nucleophilic electrophilic reagent, in general it is called NuH, the reagent, is treated in presence of a base. So the first step is base will react with the reagent to produce BH plus and Nu minus, that is a generation of a nucleophile. In the second step, what happened? Whatever the nucleophile generated in the previous reaction step will attach to the carbon, which is having plus delta, oxygen having minus delta. So this is a slow step where the oxygen attacks, oxygen shifts its lone pair of electron towards the oxygen to form minus, and nucleophile attached to the carbon, and you will get the anion. The anion will now react with the BH plus, which is formed in the first step. It is a fast step of the reaction where there is an additional product formation, C2 bonds NuOH, and regeneration of your base. So these are the two ways in which the addition reaction of a nucleophile can take place in carbonyl compounds of aldehyde and ketones. So acid, in case of acid reaction, direct H plus takes place. In case of base reaction, the base will react with the corresponding reagent and then the addition take place. Okay, so these two reactions are very essential to understand or classify the further named reactions. Okay, now let us see this reaction. Already you have learned this addition of hydrogen cyanide to aldehydes and ketone. So hydrogen cyanide is HCN. HCN ionizes to form Cn minus and H plus. Here, when the hydrogen cyanide is added to the aldehyde or ketone, the cyanohydrines are formed, RCHOH with Cn group. Okay, so I have given a specific example by taking HRCH double bond O, that is an aldehyde. When treated with this reagent nucleophile, there is a formation of cyanohydrine and acid addition takes place. Okay, now the mechanism is very clear, which involves the following step. So in the mechanism, please remember that the base OH, aldehyde ketones, when treated with the HCN in presence of base like KOH or NOH, the OH minus will react with HCN to form water and cyano group Cl minus. Okay, so the cyanide ion is formed just by reaction between aldehydes or ketone with base in the first step. In the second step, the anion Cn minus, there is a nucleophile, attacks to the carbonyl group, just I have shown by arrow mark. So Cn minus is there, it will definitely go to the carbon with a positive charge. And the pi bond immediately shifts and there is a formation of O minus. Okay, so anion is going to form. In the third step, what happened? It is the protonation. The proton present in the solvent will attack to the anion and form the Cn, COH and 2 valencies, cyanohydrines. Okay, so here we are having example. When RCHOH Cn group is there, cyanohydrines are there. So these cyanohydrine, when subjected for hydrolysis, the cyanohydrine is having C triple bond N. So it will remove ammonia NH3 and 3 OH groups attached to that cyanocarbon. And carbon with 3 OH is highly unstable. So it will going to lose a molecule of water and whereby you will get RCOH and COOH. So that I mean to say is that cyanohydrine on hydrolysis will produce hydroxy acids. Similarly, the cyano group undergo reduction also. So in presence of a particular reducing agent like lithium aluminum hydride or hydrogen in Rani nickel, etc. So what happens is C triple bond will add up 2 hydrogen to the carbon to form CH2 and 2 hydrogen to triple bonded nitrogen to form NH2. So you will get hydroxyamines. So my point of discussion here is the cyanohydrine on hydrolysis will give OH containing COH, the hydroxy carboxylic acids. On reduction, they are going to form hydroxyamines. Okay, and here I have given example when acetaldehyde is treated with HCN. There is a formation of CH3CH CNOH, acetaldehyde cyanohydrine. So this is addition of HCN to aldehyde. Similarly, acetone, if you take, it will going to form CH3 CH3OH. That is not OH, it is a CN. So acetone cyanohydrine is going to form. Okay, so this is a mechanism pertaining to this addition of cyanohydrine. Now we move on to the another important aspect of this topic. There is another reaction, that is reaction with hydroxylamine. What is hydroxylamine? NH2OH, and treated with aldehyde. There is a formation of CH3CH double bond NOH plus water molecule. So here, whatever the bonding CH double bond NOH is called as oxime. So if you take aldehyde, aldoxime bond. If you take a ketone, ketoxime is formed. So in general, there may be some time question. Explain the mechanism of addition of hydroxylamine to either aldehyde or ketone. First you have to write this reaction. Aldehyde or ketone react with your hydroxylamine to form either aldoxime or ketoxime. So I have given here specific example with acetaldehyde to form acetaldehyde oxime. Okay, now you can see the mechanism, what exactly the mechanism involved in this. Okay, so general reaction I have given. You can see RCH double bond O when treated with the hydroxylamine will going to form RCH double bond NOH oxide. Okay, in the first step of the mechanism, the protonation takes place because the H plus will going to add to the oxygen negative to form OH minus, and carbon will become plus. In the beginning itself I have told you the carbonyl group undergo polarization to have positive delta on carbon and minus delta on oxygen. Such molecule when protonated with a proton, it will going to form, that is C double carbonate single bond, and O with a lone pair of electron H. Further, when the amino group attacks, there is a formation of unstable molecule having the lone pair of electron shifted to the OH group and making the nitrogen plus. So here you can see the lone pair of electron on nitrogen move towards the carbon, and the carbon positive charge move towards the nitrogen as a plus, and the OH group attached to the carbon as it is, and there is a formation of that NHHOH. Okay, in the next step what happened, the deprotonation of unstable molecule, which is I have shown in the previous step, can take place because the nitrogen is having plus charge. So it loses a proton, that is called deprotonation takes place, and you will get carbon with two valencies OH group, and the proton on the nitrogen will be replaced, and you will have NHOH. This molecule will lose a molecule of water, that is hydrogen from nitrogen and OH group from the carbon will lose a molecule of water to yield an oxime, that is carbon with two valencies and forming a double bond with nitrogen having lone pair of electron and OH. Okay, so this is a mechanism for addition of hydroxylamine to your carbonyl compound. So please note that such mechanism may be asked in the examination, so you can take any either aldehyde or ketone and explain the same manner. Okay, now I have given an example. What happens when acetaldehyde, it is ethanol, when treated with hydroxylamine, there is a formation of acetaldehyde oxime, CH3 CH double bond NOH. This is a specific example. Similarly, acetone you can take. Acetone will again lose a molecule of water to form that is product called acetone oxide. Okay, so this is another important reaction mechanism pertaining to aldehydes and ketones. Now let us move to the addition of alcohols. So very important concept. So when addition of alcohol to the carbonyl group of aldehyde in presence of a strong acid takes place, it will going to form hemiacetyl and finally acetal. Similarly, ketone also undergo addition of a alcohol molecule in presence of a strong acid. First, it will going to form hemiketal and finally it going to form ketol. So these reactions just I have predicted here. So you can take RC double bond OH when treated with an alcohol ROH. So ROH will going to form HCHOH OR, that is called an ester, that is COR, an ester, ether. Okay, so this ether is known as hemiacetal. It is a hemiacetal. When it is treated with another molecule, it will going to form diether like compound, that is RCOR and CORH. So it is called as a acetal. If you use ketone, then ketal. Okay, aldehyde, acetyl. If you use ketone, ketal will going to form. Okay, now you can see the mechanism. Aldehyde react with the proton because in presence of acid, it will going to form OH attached and carbon cation. That will react with alcohol molecule here to form alcohol attached to the carbon. Then next protonation takes place. Deprotonation takes place. That is RCOH OH. Then again you can add a proton to it, so the oxygen will become HOH plus charge and RH, that is OR. In the next stage, a removal of water molecule will take place and you will get RCH double bond O plus R. It will now allow to react with another molecule of alcohol to form a product, and this on deprotonation will give acetyl. Well, so whatever the mechanism I have shown by downloading is very easy to see, but it is very difficult to represent on the paper. So the same kind of reaction I have shown with the different slides in the next. Okay, now you can see here aldehyde or ketone. I have given here specifically aldehyde, that is RCO. Okay, you can see. Okay, now you can see an aldehyde R C double bond OH when treated with alcohol like R1OH. So here what happened? RCOH OR1 and H. So this is your hemiacetyl formation. This hemiacetyl again react with, you can see in this next step, hemiacetyl will react with again another alcohol molecule, that is R2OH. So RCHOR1 OR2. So it is called 2-alcoholic OR, that is called a diester type molecule will going to form. So diether, it is called a diether. Generally it is called as acetyl. Okay, now my request is whatever the reaction I have shown in the previous slide, if you able to understand the mechanism in that way, it is very good. Otherwise you can adapt whatever now I have presenting in front of you. Okay, now addition of alcohols to ROH2, aldehyde and ketones, particularly aldehyde or ketone, will going to form hemiacetyl or acetyl I have shown in the above case. Okay, so this product RCOR dash HOR double dash. Okay, so here COR1, COR2, that means the two ester groups, two ether COR, it is called as diether molecule will going to form. So then what are acetyls? Acetyls are nothing but gem diethers. Gem means the carbon containing 2OR1, 2OR2. Okay, so this is a peculiar reactions you have to remember. Now the mechanism of this reaction, as already I have explained in the previous slide. So see, aldehyde react with alcohol to form hemiacetyl. RCOH reaction with R-OH to form RCOH-CH-R-. A second molecule of alcohol react to form RCOR- dash O double R double dash and H. It is acetyl. Now for this mechanism, first step you have to remember is ionization of acid, because these addition reaction of alcohols to aldehydes and ketones can take place in presence of an acid. Here the acid like HCl ionizes to UH plus and Cl minus. In the step first, protonation of a carbonyl group can take place to form OH plus and RCH. So this further shifting of a carbon to oxygen bond will make the carbon to be positive. That is a cation formation. In the second step, what happened? The second alcohol molecule adds up to give a product of this kind. Okay, RCHOH, then central carbon to carbon and R1H. The proton will be eliminated and whereby hemiacetyl, that is RCHOH OR dash hemiacetyl will going to form. In the next step, the protonation will remove water molecule. That means the H is added to OH to form HHO plus. That will be removed and you will get a cation of this kind, RC plus H, and oxygen containing lone pair of electron over it and R dash. In the second step of the reaction, the second alcohol attacks to the cation and that will going to form an intermediate product, and that intermediate product is unstable. It undergo deprotonation, removal of the proton to form acetyl, RCH OR dash OR double dash. So this is a mechanism very easy to represent and remember. Now I request you can follow either this way or in the previous slide. In the previous slide it is a little bit confusion, but in this case it's very easy to represent and understand. Now, formation of cyclic acetals. So when aldehyde is treated with ethylene glycol, what is ethylene glycol? CH2OH, CH2A. So the OH group H and oxygen of the carbonyl group eliminate a molecule of water in presence of paratoluene sulfonic acid as a catalyst. So here CH3CHO, CH2CH2O, it is a cyclic compound. So it is called as acetal, but acetaldehyde ethylene acetal. So a cyclization product will going to form. Similarly, ketone also undergoing to form acetone ethylene acetal. And if you see the mechanism is very simple to understand. So acetal ketol, whatever the structure I have shown, they undergo hydrolysis in presence of dilute HCl to reproduce the original aldehydes as well as ketone. That is, acetal will going to form acetaldehyde with the generation of ethylene glycol. Acetone will also undergo the same reaction to form, ketal will going to form ketone and the product. Well, now we move on to reaction with ammonia, reaction with hydrogen, reaction with phenyl hydrogen, which are familiar to you in your previous class. So with ammonia, like NH3 or RNH2 or R2NH. So in all the cases, there is a formation of RCOH RNH2. The OH group and H will eliminate a molecule of water to form carbon to nitrogen double bond. That is, they will going to form an imine. So what is an imine? RCR double bond NH. So both aldehyde and ketones, when treated with amino compound, amino derivatives, they are definitely going to form imines. Okay. So similarly, you can see the another amino compound NH2 hydrazine. Hydrazine also react with your aldehydes or ketone to form the corresponding aldehyde or ketone hydrogens. What is this? I have taken example CH3CH C double bond O when treated with NH2. Water will be eliminated and you will get, what is the product? CH2CH double bond NH2. So this NH2 group attached to the aldehyde or ketone is called as a hydrazone. It is called as hydrazone. So reaction of hydrazine will produce hydrogen for aldehydes and ketones respectively. Similarly, if you take the phenyl hydrazine, what is the phenyl hydrazine? The same NH2, but H is replaced by C6H5. This is called a phenyl group. So the correspondingly phenyl hydrogens are formed. Okay. So these are the simple reactions. Now I will go to the most important reaction, aldol condensation. So what is this aldol condensation? So aldol condensation is a reaction where two molecules of aldehydes or two molecules of ketone having alpha hydrogen with respect to carbonyl group. So what is this alpha hydrogen? CH3C double bond OH, for example, acetaldehyde. The carbonyl group is alpha carbon having a proton. So it is called a alpha carbonyl group. When treated with each other, okay, they will going to form or lose a molecule of water whereby beta hydroxy carbonyl compounds are formed. So this is aldol reaction. So aldehydes or ketones having alpha hydrogen when treated in presence of an alkali, okay, there is a formation of a condensed product called as beta hydroxy carbonyl compound, that is known as an aldol. Okay, so condensation between the two molecules of an aldehyde or ketone to form a beta hydroxy aldehyde or beta hydroxy ketone is known as aldol condensation. So here I have given a reaction with acetaldehyde to form beta hydroxy carbonyl compound. Okay, the mechanism involves, first step, the OH minus as a nucleophile will attach to the central carbon to form CH2 CHO and the carbon carries minus charge. So this is called as enolate anion. It is called as a enolate anion with the elimination of water molecule. In the second step, the enolate anion, okay, will react with the another molecule of aldehyde, and whereby the O will get, oxygen will get minus charge, that is HCHO and CH2 CHO. So anion of a second molecule results. Now this undergoes reaction with the water molecule. That is in the third step, the acid-base catalyzed reaction, the alkoxide ion deprotonation takes place. That is, the H will add it to O minus to form OH, and RCHOH CH2CHO. That is OH group and aldehyde group present in the same carbon. This is called as a beta hydroxy aldehyde. That is your aldol. Okay, so these are the three steps which are taking place in case of aldol condensation. Now I have made another effort to make you more simply understand what is the exact reaction. So here I am showing you handwritten. What is aldol condensation? Already you know, when the two molecules of aldehydes or ketones in presence of dilute alkali like NaOH undergo condensation to give beta hydroxy butanol. Here is an example. That is aldol. CH3, CHOH, CH2, CHO. Okay, the mechanism of this reaction just is I have written in the handwritten format. So please remember, that is the OH dilute alkali will ionize to give OH minus. OH will take a proton from CH2 group of first aldehyde molecule to form CH2 minus C double bond OH. This is called enolate anion. It will be stabilized by itself by the shift of pi bond towards the oxygen to make CH2 double bond CO minus H. So this is called as a enolate anion. And this enolate anion now undergo reaction with the second molecule of aldehyde in the second step to form anion of this kind, CH3CO minus H and CH2 C double bond OH. The anion of this will going to result. In the third step, what happened? Whatever the anion I have represented by means of a 3 to distinguish will undergo protonation by reacting with water to form CH3CHOH, CH2 C double bond OH, and acetal will going to form. It's a very simple way. So instead of the previous, you can remember this my handwritten mechanism, which is a very easy to understand with the elimination of OH minus. So okay, now aldol condensation may occur between two identical or different aldehydes. The condition is they must possess alpha hydrogen. Second one is two identical or different ketones. One condition is the ketone must have alpha hydrogen. Or with one aldehyde and another as a ketone, that is called mixed. So that will also give aldol reaction. That is a cross aldol condensation reaction. Okay, so as far as your syllabus concerned, what they are going to ask is explain aldol condensation mechanism. So better you write the two molecules of aldehyde in presence of dilute NaOH to form aldol condensation. Okay, which involves 3 steps. You write all the 3 steps and continue and end with the product. Okay, now the next one is very important, Claisen condensation reaction. So what is this Claisen condensation? Again, Claisen schemate or schemidite condensation reaction is an organic reaction in which a ketone or aldehyde holding an alpha hydrogen, remember alpha hydrogen must be there, react with aromatic carbonyl compound which do not have alpha hydrogen, and the reaction ends with beta keto ester. This reaction is called as Claisen condensation or Claisen schemidite reaction. So don't get confused with this. Okay, now here let us see what exactly the reaction is. A general Claisen condensation is two molecules of ethyl acetate CH3CO OC2H5. Okay, this is an example for CH3CO. That's an aldehyde. It's a ketonic group containing an ester part OC2H5. Okay, so CO, C2H5 and CH3. So two molecules of ethyl acetate, when treated, there is a formation or addition of these two molecules to give beta keto ester. What is that? CH3CO, CH2, CO, OC2H5 with elimination of ethanol. So here the two molecules undergo condensation, aldehydes or ketones, to give beta keto esters. Similarly, you can see here the reaction between phenyl ketone, C6H5CO CH3 with aldehyde gives beta keto ester and CH2H. Okay, two molecules of aldehydes or two molecules of ketones in presence of a base undergo condensation to give beta carbonyl ketone or beta carbonyl aldehydic product with the elimination of alcohol. This is called as Claisen condensation. Now, the mechanism of this reaction is very easy compared to the earlier reaction. So, what is the mechanism involved? RCHH, C double bond OR. Okay, so here you can see CH3CO OR. Okay, that is also CH3, you can imagine. So this CO double bond containing this alkyl group acts as an aldehyde, but this C double bond O group is again attached with an OR. So here the ester COORG ester containing CH3. So this react with NaOH and yield into the formation of anion. That is, the proton will be eliminated and carbonyl group will be C double bond pi bond will be shifted towards oxygen. Oxygen will become minus and the proton will be get deprotonated in this presence of NaOH, and there is a formation of alcohol. So you will get RCH double bond CO minus and OR. That is, the anion of this kind will going to form. Here the strong base is added to the ester to remove alpha hydrogen from the aldehydic group to form an enolate anion. This enolate anion now in the second step react with another molecule of your RCH2COR ester. Okay, the carbon to carbon shift, I have shown a long arrow mark, may occur, and carbon to oxygen will make oxygen is a negative, the more electron, and you will get a complicated molecule, but it is not a complicated, it is a bigger molecule, let us say RCH2CO minus OR, and this carbon is further connected to the another molecule of your ester to form, that is CR-H, C plus O and OR. Okay, so here the nucleophilic ester enolate attacks the electrophilic carbonyl to form tetrahedral intermediate. So it's the tetrahedral intermediate is obtained. In the last step, what happened? This removes the molecule of proton. Okay, so whatever the anion formed, that will going to show, that is a RCH2CO minus OR linked with CHR and C minus O and OR. Here the O of the second ester, okay, will shift its lone pair of electron, and the first carbon also shift its lone pair of electron. So RCH2 C double bond O, okay, C double bond O, and here the OR of the above carbon, and the proton present in solvent system will removed as alcohol. So the removal of OR will be appears as a ROH. So R dash CH2, C double bond O, then carbon with H, R dash, C double bond O, OR. So a beta carbonyl active compound that is called a diester molecules join together to form the final product. So here the intermediate collapse and the carbonyl reagent itself giving back C double bond O and relieving the uh, alkoxide to form beta keto ester. So this is called beta keto ester. R C double bond O CH2 C double bond O OR. So it is called a beta keto esters are going to form by this specific reaction. So this is the reaction which is similar to the aldol condensation, but the condensation is between the two molecules of esters, two molecules of esters. So this two molecules of ester in presence of NaOH will undergo condensation to give beta keto ester diesters. Beta keto ester. It's a diketo compound. So this reaction is called as a Claisen condensation reaction. I have explained with a specific example. So when you take benzaldehyde and treat with an acetaldehyde, there is a formation of cinemaldehyde. C6H5CHO will lose a molecule of water between OH of the O of the benzaldehyde and two hydrogen atoms of the aldehyde to give C6H5CH double bond CHCHO. So the mechanism, I have made it a little bit clear than the earlier one. You can choose either that one if you understand. Otherwise, the simple mechanism I have given for this. Okay, that is the steps I have shown for this. That's a nucleophile. OH minus will react with aldehyde to form anion. Anion react with is your benzaldehyde to give, that is CH2, CHO attached to this carbon to having oxygen negative anion. Anion will further undergo reaction with water molecule and C6H5OH CH2CHO. Okay, this intermediate product will going to form like an aldol. And here this reactant, this particular situation where the OH minus attached to the carbon CH2 C6H5 CHOH CH minus and CHO. Okay, and here the loss of OH deprotonation with H plus to form water molecule, and you will get C6H5. OH is removed, negative charge will be shifted in between carbon and carbon to form double bond CH-CHO. Cinemaldehyde will going to form. Okay, this reaction. Now the last type of reaction. Here this reaction is nothing but Perkin condensation. What is this Perkin condensation? When benzaldehyde is allowed to react with acetic anhydride. Excuse me. Well, when benzaldehyde is allowed to react with acetic anhydride, that is CH3CO COCS3, in presence of sodium acetate CH3CO minus undergo condensation to form benzene ring with C, okay, double bond COH. So cinemaldehyde will going to form. So this reaction is called as a Perkin condensation. Benzaldehyde, when treated with acetic anhydride in presence of sodium acetate, there is a formation of alpha beta unsaturated group attached to this benzene, that is nothing but cinemaldehyde. So this reaction is called as a Perkin's reaction. So in the Perkin reaction, you can see what exactly happen is, that is okay. So this is the second part. I don't want to go for the second reaction as far as your syllabus concerned. So you take the first example, that is sufficient. That is, benzaldehyde react with acetic anhydride to form cinemaldehyde. Okay, so just I have given. This Perkin reaction is used for the synthesis of alpha beta unsaturated aromatic acid by condensation of an aromatic anhydride and an acid anhydride in presence of an alkali salt of acid acting as a weak base, resulting into alpha beta unsaturated aromatic acids. So generally such type of reaction is only applicable to aromatic aldehyde and useful for the preparation of substituted cinnamic acids. Okay, now you can see the mechanism. The mechanism is very simple. The Perkin mechanism, acetic anhydride. What is that? CH3COO CO CH3. The proton of acetic anhydride undergo reaction with OAC, that is OCH3CO. So ACOH protonation will remove, and that will going to form the anion of this kind, right? So you will get CH3 COO O minus and double bond CH2. This will react with your aromatic aldehyde. So aromatic aldehyde is having carbonyl group. The carbonyl group is generally minus oxygen plus carbon. So the negatively charged oxygen on the acetic anhydride part will shift its lone pair of electron towards the carbon, and the double bond will shift towards the aromatic group, and AR, this typical molecule will going to form. Okay, so AR O minus attaches to the anhydride molecule, and here you will get C double bond O, then O CO. Okay, so intermolecular cyclic product with negative charge will going to form. So this molecule is now shift the lone pair of electron from the negative ion towards the C double bond O, and a cyclic product will going to form. So this cyclic product will react with another molecule of, that is your CH3CO COCH3 to give this product. Okay, and this product again react, and it will going to form illuminated product. Okay. Now let me not to take this as a granted. So I will explain the mechanism of this Perkin condensation next time. So meanwhile, whatever the reactions I have discussed, so please note them very carefully and be attentive for all these reactions and be prepared for the best in the chemistry part. So with these words, I conclude my class, online class, saying that wear mask, keep social distance, and sanitize your hands regularly. Keep yourself fit and make the entire world happy. And follow the most important rule is keep yourself in safer side at home. So with these words, I will conclude this today's episode. Thank you. Thank you. If you have any queries, any problem, you can call or ask the questions in the chat box. Okay, so thank you.